Hi everyone, I'm Chris Saxon. I'm part of Stephen Feuerstein's Oracle Developer Advocate team. It's my job to help you get the best out of Oracle database and hopefully have a little bit of fun whilst doing so. So it's always great to be here for these office hour sessions to help you understand how to work effectively with Oracle database. So this week we're going to be looking at something, a really common problem, and that's how to actually figure out what SQL statement you should be tuning in the first place. In previous sessions, we've looked back, you've got a slow SQL statement, and you're kind of like, well, how do I fiddle the execution plan? How do I create indexes and so on? How do I make that faster? This time we're taking a step back and say, well, how do we even know which SQL statement to look at all? So let's say, welcome. All right then. All right then, yes. Yeah, so Soren, yep, the slides are now up. I was just introducing myself, so while we had the video up. Alrighty then, so this is a situation which I'm sure you're probably all reasonably familiar with one way or another, and that's someone out there is complaining that the database is really slow. They're like, this is just taking forever, my screen won't load, or my code takes forever to run, or whatever. It's taking a long time. Hurry up, make it fast. Make this as fast as you possibly can. So the challenge is you then need to figure out what particular SQL statement it is that actually is making things slow, or which set of SQL statements are making it slow. And there's a couple of things to bear in mind here. First up, you really need to kind of scope in exactly what it is they're complaining about. Often people kind of just say, everything's slow, when really they just mean their particular screen. You know, they're searching for orders, or they're trying to load up the unpaid invoices, something like that. When they say the database is slow, really they mean their specific thing is slow. And it's important to drill in on exactly what that is, because if you look at overall system metrics, like you might get from AWR reports and the like, you might start tuning something which is completely unrelated to that problem. So you need to hone in and find out, well, which code runs when they click the button that they say when this is slow. And then once you've found that code, you then need to look at and say, well, which part of that is the slowest bit? So let's say we've scoped this, we've spoken to the users and gone, okay, we know when they click create order, that it takes much longer than they want it to. And when they do that, we've got a procedure that runs, which runs some SQL a bit like this. So we've got an insert, some queries, we do a bit of looping, do a bit more inserts. Now the thing is, when you just kind of look at code in the abstract, it's actually quite hard to tell what the slowest parts of it. So we've got an insert statement at the top. How can you tell just by looking at it what's slow? Well, you can't really. You know, that insert at the top, does it take 1 microsecond or 1 minute? You know, it's not obvious. They might go, well, we've got an insert with the values, so a single row insert must be pretty quick, right? Well, what if there's some triggers on it? What if that table is in fact a view? Maybe with some, instead of triggers on, that spit out into all sorts of different tables. There's all these kind of complications which are not immediately apparent when you're trying to tune the thing. What if you've got clashes on primary or unique keys, and the code itself is run fine, you're just blocked because there's another uncommitted transaction somewhere else in your database? You know, you don't know. What you need to do is kind of profile this code or trace it to see, for each individual component, how long does it actually take to execute? So the idea is you'll end up with pie chart, graph, whatever you want to say, something looking something a bit like this. So we've got a breakdown of each individual statement and say, of the total runtime, how much of that does this contribute? So if it takes 10 seconds, we can say statement 1 here, 45%, so 4.5 seconds to run that first statement. That's probably where we want to start looking and focusing our efforts. You know, we want to start looking at the biggest consumers here and ignoring these other bits, which are a relatively trivial fraction. So, you know, we've got statement 4, 7%. Even if we completely eliminated that, we're not going to make a noticeable difference to the typical user about how their SQL statement's actually executing. So we need to kind of break the code down as it's executing, see what it's doing, so we can get this information and reconstruct it using whatever tool you like to build these kind of charts. So I'm going to talk about 3 ways you can do this in Oracle database. So the first one is the kind of manual roll your own approach. That is logging, instrumentation. This is where you put stuff into your code to say, after each statement or after each critical component, timestamp it, say what's happened when. And this requires some upfront investment, so we need to build that into the code. Next thing I'll look at is a SQL trace. So this is something that's been built into Oracle database for, I don't know, as long as I've been using Oracle database, so well over 15 years. And this is something you can turn on and off in sessions to capture SQL execution statistics. Very, very useful. Finally, as well, I'll talk a little bit about the PL SQL profiler. So you've got a procedure, anonymous block, whatever, and it does a whole bunch of stuff. How long do each of those individual components take? So we'll look at those and have some demos to talk about how they all work. So we'll start talking about logging. As I said, this is something you need to explicitly put into your code. So after each key point, you'll say log to some information to the database. Key things you need to capture here is the actual timestamp of the log when it actually happened. So then you can kind of do the differences and say, well, this took, subtract the next timestamp from the previous, say it took that long. Also some kind of session ID or other context information, so you can tie it all together. So this is really useful to help you figure out where slow parts of your code are. But even ignoring the performance aspects of this, I think this is still something you should do anyway, because it makes debugging your code much, much easier. You can put all sorts of contextual information into that log, any variable values, any session state or global information you've got set up. You can log that and capture it, making it easier to debug as you go along. Particularly useful if there's a problem in production that you cannot recreate in your test environments. If you've got logging and you can just enable it or disable it for particular sessions or system-wide, you can enable it, capture details about what's actually going wrong and go, okay, it's this particular customer who places this type of order, that's when they hit the error. So then you can recreate it in your test environments. So logging is very useful for performance investigations, but it's exceptionally useful to just keep your application running, debug it, keep it up and running, make sure everything's running smoothly. So this is something I should recommend you do. That said, I recognize a lot of you probably use existing applications where there is little or perhaps even no logging whatsoever. So this is a bit of a problem, right? This is upfront investment you need to do. You actually need to write code, put it into your application so that you can enable it or disable it. If you've got performance problems now, you probably don't want to have to wait for someone to kind of crowbar all this logging information in, do a release, get it into production before you can actually capture that information. It'd be better if you can just say, right now, let's start analyzing what's actually going on. So to do that, as I said, there's the SQL trace, something that has been around for a very long time in the Oracle database. Some of you may know this by a few other names. So there's something called the 146 trace, which again has been around for a very long time, but the kind of accepted, or the best way to do this now is to use this DBMS monitor package. And what we can use this to do is enable tracing within a session. So we can say, start tracing our session, run our code, stop tracing, and then we can analyze the trace file. Now the thing to note here is SQL trace creates a file on the database server. You then need to kind of get that file off the server, run it through some kind of tool to analyze it, and then you can actually start looking at what it means and doing something useful with it. I've got a demo coming up where I'll show you walkthrough steps you can use to do that. But just tracing in itself kind of doesn't appear to do anything. The files are created on the server. So nice things about SQL Trace, it's completely transparent to your code. So like I say, if you've not enabled, if you've not put any logging in, doesn't matter. SQL Trace will capture execution details for that SQL. You can also use it to capture details about other sessions. So quite often, in production, there'll be some slow session that's running, and you either don't want to or are not really able to run your own version of that code. So you can just enable it in the other session, capture the details of that, switch it off again, analyze the trace file. So it's transparent to use, for you to use, and you can enable it for other users. And it includes lots of details. Hitting my keyboard there and blanking the screen, sorry about that. Lots of details about the SQL itself, so things like the execution plan, making it very easy for you to kind of see, okay, well, what do I need to start doing to actually make the SQL statements in here faster? So very useful tool. The final thing we're going to talk about is the PL SQL profile. Process for using this is quite similar to the SQL Trace. You kick off the profile, you run the dbmsh procedure, run your code, and then you stop profiling. Big difference for this between this and SQL Trace is the profiler doesn't have a mechanism to kind of say, start tracing in some other session, capture details from some other user session who is connected. You start it, run your code, and stop it. There are kind of ways around this where you could do things like create logon triggers and so on and so forth. But principally, the API itself doesn't offer a way out the box to say, I want to trace someone else's session. But one good thing it does have over SQL Trace is it captures details about PL SQL execution as well. So SQL Trace, as the name kind of implies, only captures details about SQL statements. You've got a lot of PL SQL code, turns out that's slow. The PL SQL profiler will capture that as well as the individual statements within your code, so you can see what's going on there. So that's kind of a bit of an introduction to these various things. I'm going to start jumping over to a demo on these. Any questions or comments on that while I do? Let me just have a drink. Okay, not seeing anything coming in. So what I'm going to do is I've got this create order procedure, and I'm going to look at ways to trace it. I'm not going to demo logging because that's very unique to your scenarios. It's up to you how you've actually written your logging and what you've done. So it will be very specific to your environment. I'll just look at using SQL Trace in a hierarchical profiler to capture the execution details. So we've got a whole bunch of things going on here. And some of you might look at this and go, I think I can see where this is slow, but just hold that thought. We'll go through the process of tracing it and finding out what the slowest parts are. First thing we do, just find the order date, insert the header. So we're going to create orders and order items. So we insert the order. Next, we get the order ID, doing a rather interesting statement here where we try and pull out the order we just created. And then we're going to add the order items. So what this does is it adds all the orders, all the items for all the products that are colored black and white. So first up, we find the black products and insert them into order items. And then we do a very, very similar thing where we find the white ones and insert those as well. So like I say, some of you might be looking at this kind of going, cringing a bit and thinking, well, maybe there's some ways we've got to make this faster. The point here is I want to kind of demo how we go through tracing it and splitting it out like this makes it a lot more obvious where some of the pain points might be within this. So just seen a question from Pranjal. Will you provide the slides after the session? So a recording of this session will be made available shortly after, so sometime later this week, hopefully. So just if you subscribe to the session, you'll get an email when the recording is available. If you're not, then you just check back on the Office Hours page when the recording's available, it'll appear there. Okay, so we've got this create order process, and I'll just execute it, prove that it works, bring that back up, and it will say we've created an order. So what I want to do, first thing I'm going to do is do a SQL trace of this. So session trace enable. So I've got these weights and binds equal to true. So why have I done that? Well, the weights captures weight information, unsurprisingly. So things like if we've got slow disks, so it's taking a long time to do write, or maybe we've got clashes on primary key. We're waiting for someone else to commit their transaction so we can insert a primary or a unique key value. So weights information, very useful to capture. Again, binds as well, tells you what values the SQL statement actually executed with. So most of the time when I'm doing this, I set these to true. They default to false. So I usually set them to true, but do be aware, particularly with weights, this can generate a lot of data. So if you've got a session stuck waiting on whatever it is, it's just going to keep writing and writing and writing that to the trace file. You can quickly end up with some really colossal trace files on your file system. So just be aware of that, and it's the kind of thing you might need to talk to your DBAs, storage admins, and about to make sure you've got capacity to capture that information. So we'll enable it, run the order, and disable it. So there we go, and it's run away. Hopefully that's all executed fantastically. Okay, so we've captured this trace information. So we get it, right? Where is this trace file? Well, we've now got this $diag info view. I forget exactly when it came in, but it's been around for a while now. And you can see it tells this value, if we look for the default trace file, this is the exact location on the database file server of the trace file. So we can pull it all out and we can get that individual file name. So if you log on to your database's server, you can go to that location, get the trace file. Nice, but a lot of us, particularly if you're just a lowly developer, do not have that access. You go, please, Mr. DBA, sir, will you please let me access these trace files? And they go, nah. No. There's no chance on this earth you're getting access to the real physical kit for your database, particularly not in production. Maybe in test and development, but certainly not in production. So how do we actually get this trace file? Well, something I actually learned today, to be honest, admittedly. There's this lovely $tracefile contents view, which was added in 12.2. And what we can do is by pulling out the trace file name, we can see what is actually stored in that file. What information was written in there. So we query that, and you can see there's a whole bunch of setup information. And you can see, we've got our select statement, select from orders, and a whole bunch of, looks a bit gobbledygook stuff, but information about how it's actually processing the SQL statement. So we got all this data, and okay, it's useful if you've got lots of time on your hands, you can walk through these trace files and kind of read them to figure out what's going on. Personally, I don't really have time for that. It can be quite tricky to see what's going on. So there's various tools you can use to format and see what's going on here. So what I'm going to do is spool the contents of this for the current session to a file. So I've got a little script like this, does some setup stuff, spools to my trace file, runs the query, and gets it out. So let me just run that. So we've got that file on my file system, and you can see there's all the stuff it's traced. Like I say, not particularly readable. I want to get this in a way that we can actually understand as people. So in order to do that, we've got this handy little tool called TKProf. Again, this is something which has been abound for a really long time. It's a client tool, so it's part of the client libraries. So if you install the full client, including SQL+, stuff like that, you will have TKProf. I don't believe it's included in the instant client, so just be aware of that. But as long as you've installed the full SQL+ client, you will have TKProf. And the simplest thing we can do is pass in the name of the file that we're actually tracing, so order trace, and the name of the file we want to spit results into. This will go through and parse it and give a bit of information, and now we've got some more readable details about what's actually going on. So now let's look at this file that's just created. So we've got some setup information, and it's telling us details about what's captured here, and we can see all our individual SQL statements. So we've got our select, our insert, our select, our select, and we've got execution details about those below. And yes, and sadly, when you first capture it, it doesn't always capture the execution plan. So here's one I made earlier, which does have all the execution plans. So let's look at this insert statement. What is this telling us? Well, we've got a breakdown of parse, execute, fetch. How long did it take to do each of these individual components? So with write, inserts, update, delete, you will only see parse and execute. There is no fetch phase for those. You only get fetches with queries. And we can see elapsed time, total time, 0.1 of a second, so 10 milliseconds. Pretty quick, right? So this is pretty quick. And it's telling us no disk reads, so we didn't have to do physical reads, some consistent reads from current rows, and it wrote one row, and there's an execution plan. Now, insert with values, not particularly interesting, unless it's doing something like crazy going to a view. Most of the time, these are pretty boring. Let's find one a bit more interesting. So remember I had that query, so we could pull out the ID of the order we just inserted. So something a bit like this. So we've got this here. So what's going on? Now notice the queries here are all pretty quick. Servers these days are really, really fast, and my data volumes aren't that huge. But we can see, looking at the execution plan, this does a full scan of the orders table. Oh dear. So this is, not going to scale very well. It might be fast now, but week, month, year down the line, will this do quite so well? Probably not. Something we want to watch out for. Okay. So Raj, question. Parse means, please, is it TK prof will show B1 value? I'm sorry, Raj, I'm not really sure what your question is there. Could you just, if you could rephrase it slightly to clarify what you're asking, that would be helpful. So we can see we've got a full scan of our orders, and the tip off that this could be doing something that's quite slow here is query. How many logical IOs are we doing here? Over 300. Quite a lot of work. 300 IOs to find one row, it's a lot of work really, isn't it? So that's not great. Next we've got our other query, one of the other queries to find the black products, and again we can see we've got another full scan here. We're doing well here. We're doing well here, aren't we? All right. So, and again, this does a fair bit of work, but it does find 9 rows. A little bit better, I guess. So another slow aspect here, and we can see our inserts. Now, this is kind of an interesting thing here. So one of the things you want to look at is how many times you've executed the SQL statement. So we can see on this execute line, we've executed it 12 times, and we've inserted 12 rows. That means, on average, each time we've inserted just 1 row. It's an insert with values, so that's kind of what you would expect, really. In general, doing things 1 row at a time scales very, very badly. So again, there's things that we might want to do to kind of see how we can improve the performance here. And finally, we've got the white ones. So we get a nice, good breakdown of what's going on. Now, in this case, the whole procedure was super, super quick. As we can see at the bottom, in total, the entire thing took 0.13 of a second. So, a tenth of a second, a tenth and a bit of a second. It's fast enough that most of us won't even notice. And you'll see for a lot of these things, it's just reporting 0 for the elapsed time. Now, clearly, it can't have taken no time whatsoever, right? It must have taken some time. The problem here is that computers, they're just so fast these days that doing, working on small units of data, the units here are just too small or too large, not granular enough. So we can't really see a good detailed breakdown of which the slowest real components are. We can get some idea, and maybe at this point something would have stood out to us. Maybe we'd have seen this statement and say it would taken 10 seconds on its own or something, but it's not immediately obvious what the slowest parts are just by looking at this. Okay, questions on TK-Prof trace files before I move on. Okay, so Mani Kandan, without DBA administrator, am I able to store a trace file in my local machine? So that's a good question. So like I say, the trace file itself is on the database server. To get it onto your local machine, what you want to do is query this $trace file contents and then spool it to a file or export it to a file, whatever your favorite method of getting rows out of the database into a file is. So you use this $trace file contents. Like I said, this view was only added in 12.2. If you're on older releases, you'll have to do something. You'll have to get your kindly DBA to set up an external table which points to that location, so you can pass in the file and point it to different files. But ultimately, you want to do something a bit like this. Or maybe you've got a nice friendly DBA, or you're lucky enough to have server access, and you can SCP, copy it over one way or another. So this is the way you want to get files from now on. Okay, so hopefully that helps answer. So I've seen a whole bunch of other questions come in, so let's look at these. So PenMap, what's the difference between this and alter session sets equal trace to true? Short answer is that they're basically exactly the same thing. The big difference here with DBMS monitor is you get control over whether or not to include those waits and binds. Off the top of my head, I think SQL trace excludes waits and binds. I'd have to check, but second trace enable allows you to flag either one or the other depending on what you want. The other big difference in as well is that session trace enable allows you to trace somebody else's session, right? With alter session set SQL trace to true, you need to do that in your own session or set up a logon trigger or something like that to enable this. With DBMS monitor, there are session ID parameters so you can enable it for someone else, but basically it does the same thing. So hope that answers the question. So Martin, can you see the bind variable values, perhaps in raw trace file only? Yes, so you will see in the raw trace file, you see lovely things like this, bind, lovely, hopefully there. So we can see bind 1, value 11, value 4. So you can see these bind variable values here if you go into the raw trace file. If you've got one big SQL statement that's taking a minute to execute, digging through the file to find these isn't too much of a drag. But when you've got like lots of little statements like this that are running inside a loop, it can be a bit more painful. So you can see those there. Okay. Wilson, would it be possible to get information about adaptive features that were in place for the plan execution chosen by the optimizer? That's a good question, Wilson, and I don't know off the top of my head. Let me just go back to the formatted trace or the trace. I thought that somewhere it did capture some information about your session settings, but I could be wrong. Okay, short answer is I don't really know, Wilson. Sorry about that. Yeah, I'll have to look into that. If anyone else has any knowledge about that, just let us know. Okay, Ingimunda, is it possible to name the trace file something so that you can easily find it on the database server? Very good question, Ingimunda, and something that you can indeed do. So there you go. There's this alter session set trace file identifier. You can see I've named it Chris here. So you could call it whatever you like, tracing production problem. And then once we've done that, when it creates the trace file, it will be instance or service name, blah, 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 blah. There'll still be some prefix before it, but it will have the identifier at the end, yes, making it much easier to pull that out. So very useful if you want to get that extra information. Alrighty. Okay. So I see one last thing I think I'll cover at this moment. So what are your suggestions for TK Prof, sort, sys, etc.? So another good question. Animal, I'll just very quickly show some of the parameters here. Whoa, lots of stuff going on the screen there. So one of the most useful formatting options for TK Prof is this sort option. And you can see there are a massive stack of things you can sort the results by. So by default, that file we get is just the order it executed statements, or the order it captured them in the trace file. If you want to find the slowest of those, sort them slowest at the top, fastest at the bottom, probably the way you would tackle these things. There's these various elapsed columns. So perhaps the most useful usually is the exec elapsed, just the total time it took to execute that particular SQL statement. So just sort exec elapsed is usually what you want. Maybe you want to be a bit more target, there's a whole bunch of various other things you can fiddle through should you wish to, but mostly in my experience, I really just use that. But you can sort by all those other things should you wish to as well. Okay, okay, just saw it from David Kurtz. Other trace profilers report wine variables, TKProf doesn't. I think you can't see optimizer parameters in the trace file. This is captured in $4 SQL plan. So thank you, David. It's worth mentioning as well, there are various other tools available which do support, trace files, formatting them and reading them. I've just used TKProf because it's nice and simple and can run it in the command line included as part of your instant client, the SQL client. But a whole bunch of other things you can do with it as well. So thanks, David. All right then, I think we'll move on. So that's covering the trace files. Let's move on to the profiler. So let's profile this code and we run our trace there. So there are a couple of things you can do here. So you could call these procedures manually. There's dbms hprof, create the order, stop the profiling, and then analyze it. So we can run that, and that will run the profile on it. And that will then spit it into the dbms HP tables, which, I need to capture my run ID, 129, there we go. 129, if I can run this. And we can get it out with a lovely, rather large SQL statement like this. So we can use that to see what's going on here. This works, but personally I prefer to use the SQL developer way to do this because it's just a bit more intuitive. So we can right click it, just click profile, we'll run it. Maybe we set up some parameters we want to pass in, give it a comment and so on. One very useful thing I would do here is this gather SQL statistics. Click that so we can get execution details. So I'll do that and refresh this, and then we got our execution details. So there's a whole bunch of stuff going on here. Actually, I'll start over on the far right. So the call hierarchy is kind of walking through the code down bit by bit what's actually going on here. So I've got no nested functions or procedures, so everything just appears under create order, and we can see what the elapsed times for those are. So to find the slowest parts, we want to sort here by function. This is the time it took to execute these. So these values are all in microseconds, so tiny values, right? I said that the 10th of the second in TKProf was too small. All these things are running pretty quick. So we can see here at the top, we've got 4 or 5 things which are taking up most of the execution for this. And we scroll over, we will see exactly which line of the code they're on, very handy, but also the SQL statement. If it is in fact a SQL statement and not some PL SQL. Now, the reason I want to capture SQL details is if you double click the SQL ID, it will bring it up. Lovely. Let me just format it so it's a bit more obvious. So that's our finding of the black colored products. And there we go. We got the execution plan for it as well. We can see doing a full scan of products, so on and so forth. So this is pretty useful. We've got a nice way we can sort our information. If it's the SQL statement attached, we can actually drag that up as well, pull that out with SQL Developer 2. And we've got a lot of other information about what's going on here. So looking at this, we probably want to say, well, these things, certainly the top 3 or 4 or 5, most of the time is going on those. So those are the things we want to look at in our SQL, in our trace to figure out what's actually going on. Okay, so questions, comments on the profiler. I'll just show you briefly as well. You can see the module, pretty much everything's going. If I call multiple different procedures here, so create order, view order, something like that, have different things. See, most of the time, 97+% is on SQL. Very little time is on field SQL. So we've got some SQL tuning to do and how it all fits in the core hierarchy. Okay, let me just look back. Tiago, do you use tools like Aura SRP or Profiler? So I'm not familiar with Aura SRP. I don't know it. So Profiler from Method R. So that's something you can do. I mean, there are a lot of tools that you can use to do this. And you know, I've just shown TK Prof because it comes with what you've got with your client. It is just one of many ways you can do it. The key thing to know is just it's about how you actually generate the trace files. Try some out, find which works best for you, and you know, have a go really. Okay, Wilson again. So what should be done to reduce the impact that the profiler could have on a production workload? So this is it's a good question, Wilson. So a couple of things to note there. So well, I'm not sure which profiler you're talking about, the SQL Trace or the PLC hierarchical profiler. So I'll start with SQL Trace. So enabling SQL Trace does add some overhead itself to actually running the SQL statements. And as I said, it generates those trace files, which can get very, very large, very, very quickly in some circumstances. So just be aware of that. So that will slow things down. Typically, you only want to enable this when you are investigating an issue. Enable it, get some data, switch it off again. You don't want to leave it running forever and ever and ever, generally speaking. The hierarchical SQL profiler, on the other hand, doesn't really have a way to do that. It doesn't really have a way to kind of say, well, enable for somebody else's session. Okay. Now, you could do things like set up a logon trigger to start the profiler and have some appropriate point to stop it again. You know, particularly if you've got lots of sessions connecting, running the profile and disconnecting. Your session applications probably shouldn't be connecting and disconnecting a lot like that. So making this tricky to manage. But there isn't really a way to do that with a hierarchical profiler, making this tricky to use in production, right? So like our create order here, good chance that you just can't run this in production. You can't run create order because, you know, it's a real system. It's a live thing. And as soon as you do that, you're potentially causing problems further down the line. Now, I know quite a lot of companies do then have some form of test customer or test products that you can use, so you can do the live testing. A couple of things to note on that. First thing, you need to be really sure that you clean up after yourself when doing this. I worked for an airline and we had test passengers where we could do things like test check-in, make sure all that process worked. one time someone did this, checked in a test passenger, forgot to check them out, and there was actually a live announcement at the airport. Would a Mr. Testing, please, come to the gate, the flight's about to depart. So you'd think that maybe the staff at the gate would have realized that it's probably not a real person, but even so, it's easy to forget to clean up after yourself. So testing right processes like this is just tricky in production. The other thing is as well, often, particularly in tricky to identify issues, the problem is specific to a particular customer. It really is down to the particular product they're ordering, the customer who's doing whatever it is. You've got that frequent flyer passenger who flies every single week, so they've got masses and masses of reservations with you. That's the reason they've got performance problems, is because the code which works for everyone else, because there's only got one or two, is now suddenly very slow because they've got a massive backlog or load of active bookings at a particular time. So testing in production is always tricky with rights, and it's just tricky to do this with the PL SQL profiler. Okay, so Raj, when I am opening the profile for one procedure, is asking about the sys password to create the directory. So yes, good point, Raj. There is some setup work you need to do. You notice here it's writing this file. So you need to do some configuration. If you just follow the steps in SQL Developer, it will tell you what you need to do. This has changed in recent releases, so it uses actual real database tables rather than writing to a file in the file system. But in any case, there is still setup work you need to do. There's various guides on the internet. I can add some links to this session if you need to know more about that. Okay, Wilson Bernard. A good feature for the hierarchical profile will be kind of a randomic execution. I'm not quite sure what you mean by that, Wilson, but if you could explain more, that'd be good. Okay, Ingemunda, is it possible to combine Profiler and UTPL SQL for testing? UTPL SQL should clean up for you. Presumably, yes. I mean, it's all just PL SQL. If you can call it and run it and do what you need to do, then yes. Again, would you have your unit testing framework deployed in production? Probably not. I'm not sure many people, DBAs and so on, would be happy about that. But I don't have huge experience using UTPL SQL, but you're just calling PL SQL. You can run a script, call some PL SQL. I mean, even here, if we've got the profiler, you can stick whatever you want in here. Set up stuff, whatever. So it's up to you to, as long as you can got procedure to call, you can do it. So it's just caveats about being careful. So Tadeo, you mentioned triggers could be a problem when inserting rows. Best way of tracing profiling the trigger code. Does the trace profiler show the actual code in the trigger, or everything falls under the actual insert? So with the SQL trace, when you've got extra SQL statements in the code, they will appear as their own things in the SQL trace. With the profiler, however, I'm not sure. I'll have to check. I think that they just appear under that SQL statement itself. I'm not sure on that, Tadeo, but it is something to watch for, yes. All right, if you've got more questions, just keep them coming. This is good. Things sounds like we've got lots of thoughts about how to use this and what to do with it. Okay, so we've got our profile. And what I'll do is I'll just jump back to the slides very briefly. So I've done various runs of this many times, and to kind of get some average idea of how long the parts of this code were slow for. So let me get my slides back up. So we've got that pie chart. We've got the pie chart showing how long each individual component actually takes to run. And we can see the majority of time is going Slack from products. I notice I had two queries there, one for white, one for black. I've just piled them together because the same query really, it's just different value. We've got our insert to order items and our select from orders, and then finally the actual insert itself. And there's a bit of PL SQL in there, which had pretty trivial, very tiny amounts of time there. So really, we want to tackle what this select from this product query. Probably have a bit of a look at this insert and this select as well. See what we can do about those. So let's go back to the slides. And so we had our insert at the orders. That was the bit that was taking about 7% of the time. Not much we can do there, really. We can probably ignore that. Then we were selecting that order ID. Remember, we had that full scan, taking 20% of the time. Yeah, reasonable chunk. And now the interesting thing here is we've got our inserts and our looping through the products. Combined, they take 70% of the time. So clearly, sorting this bit of the code out, remember, really it's actually 2 bits in my real procedure, is going to make us the biggest gains here. So now we've kind of got this overview. How do we want to go about fixing it? So let's see if we get some suggestions, with ideas from the audience. Select, get the timestamp, insert the order, query the order back out again, loop through the black products, insert them, loop through the white products, insert them. So this is the bit we really need to target, this whole section, these 2 sections here, but we might want to see if we can do something about this as well. So suggestions in the comments, who's going to be brave and come up with a way we can make this all faster. Okay, just seeing Wilson, you've come back with about the randomic stuff. A way to execute the hierarchical profile routines inside a procedure for some of the executions, like a sample block select clause. I mean, I'm sure you could code your own way of doing this. You're just calling PL SQL procedures after all. I'm not sure exactly what the use is, but have something like, take the modulus of the type, 10th of a second, and if it's 1, then, do this, otherwise whatever. I'm sure you could code up a way. I'm not seeing. Okay, so we've got some suggestions. Index on date column, function-based index on the JSON value would help. Okay, good suggestions. Anything? What about something a bit more radical? We're just, we could create some indexes, so those would probably help a bit. But bulk insert from Martin. Okay, can you expand what you mean by that a bit more, Martin? What you would try? And replace the row by row insert with for all. Okay, so that's yeah, we're starting to get somewhere. We've got an insert within a loop. And generally speaking, if you're running SQL inside a loop, it's going to be slow, right? It's although each individual execution can be really quick, just the overhead of starting each one becomes non-trivial. This becomes even bigger if, let's say, this isn't a PL SQL procedure. We're driving that loop from mid-tier code, from Java or C# or whatever it is. Got that loop in our Java code, and each iteration you insert something, so you go all the way to the database, all the way back again, n times. You potentially got slowing things down significantly. So we could do for all bulk insert, but we don't even really need PL SQL here, right? Why do we need for all? What's insert select with black for case black white from Mike? There we go. That's what I was looking for, Mike. Thank you. Sure, we could do something like bulk collect these in first, and then do a for all insert, or we could, if I just scroll down to wherever my procedure is, just insert the query, right? We're not doing anything particularly special to the values we're selecting here. There's no manipulation of them further inside here. Now, maybe if we got these values out and we had to do, I don't know, some conversion of the prices to sort out currencies and so on and so forth. Maybe we would have to bulk collect first, do currency conversion stuff, and then insert it. But here, we've just got to select, we've got a query, we've got an insert, just insert the query, right? So we can do that. Another thing we can do with us mentioning that query to look up the order.id we just inserted. Well, that's a big waste of effort. With our lovely returning clause, we can just get value for it. So we can eliminate that SQL statement entirely, remove that ticking time bomb of the full scan that's potentially there. So let's run this again. Let's recompile that, and I'll run the profile again. So let's do this. Do it 2 or 3 times. It's always useful to get a few executions because particularly the first time you run it, there can be some parsing overhead and so on, which can slow it down. Let me just. We can see we made a big difference here. We've dragged. We were taking 15 milliseconds. We're now down to 5 milliseconds. These are pretty trivial figures in the whole grand scheme of things, but hopefully you can see we've made quite a big saving here. And now we've pretty much all our time, 80%, 87%, getting on from 90%. Yeah, about 90% of the time is just in one SQL statement. So this is our insert into order items. And we look at that, format it up. So we got our insert query, and we've still got that full scan there. So maybe we want to create that function-based index you were talking about, Judith. Let's try creating that. Let's create that index. I'll just gather stats, force it to make sure it actually picks up the new execution plan. And again, let's run this a couple of times, a few times, profile, and hopefully it'll be faster again. Let's see what happens. Yeah, so the first execution's quite slow, passing overheads and so on. Then we're down to 2.5, 3.5 milliseconds, so roughly halved again. And if we look at the SQL execution stats, hopefully, yeah, there we go. We've got the index, hooray! So we can see what's going on there. Alrighty then, we are running up towards the hour. So that was kind of what I wanted to show you on the demo. Just kind of wrap up quickly, a couple of things to think about. So we looked at 3 different techniques here. Custom logging, SQL trace, PL/SQL profiling. You're like, well, which should you use? Now, the thing to note here is they are not mutually exclusive options. You can use all of them at different times and in different scenarios. And in fact, you may need or want to. So they've all got their strengths and weaknesses. So the first thing is we have a little table of things they do or don't do. So SQL execution stats. So when you're using custom logging, I mean, okay, admittedly, you probably could write your own thing to capture stuff from VDOL, plan stats and whatever, but probably not wise. So manual logging generally won't really capture any SQL stats other than how long it took. Whereas the SQL trace, that's exactly what it does. Probably should have a little asterisk next to the profiler because it does that if you use it in SQL Developer with that little, gather stats thing. Thing to remember is that profiler is working within your session, doesn't have an API to execute it for other sessions. SQL trace does, and a good logging framework should also allow you to selectively enable it and disable it, so you can get it running for a short period of time for sessions. Very useful in production. One big advantage that logging does have, I've got context info, but I think mean things here like variable values, global values, maybe session settings. Yes, SQL trace captures the bind variable values, but or if you tell it to, but it may not have other contextual information about where the SQL statement fits in the process, if there's anything else going on. Whereas custom logging, you can write whatever the heck you like in there, right? So capture as much information as you need to make it useful for debugging. Biggest drawback of the SQL trace is that, of course, it's only SQL. It doesn't capture PL SQL, whereas logging and PL SQL profiler both do. That said, modern computers are so fast, unless you're doing something incredibly complicated with PL SQL, chances are it is just so fast, it's not really worth worrying about it. Usually, it is SQL that dominates the profile in terms of runtime. Maybe if you're doing some advanced number crunching or something in PL SQL, you might need that information, but almost always it's a relatively small fraction of the overall runtime. And finally, the SQL trace and profiler are kind of transparent. You can just set them up, run them. You don't need to change your code at all. Whereas, of course, custom logging, instrumentation, you need to build that in. If nobody built that in when code was originally developed, you're kind of stuck, right? So please start doing this when you are writing new code. Makes your code easier to debug, but it also makes it easier to trace and see what's going on. If you haven't got it, and even if you have got it, you can still augment it with SQL Trace and the PL SQL profiler. So to recap, figure out the slowest statements. First thing you want to do is create that profile, capture the execution details for each statement, and then find what the slowest ones are. Look at those slow ones and say, how long do they take to execute? And then focus your tuning efforts on those slow components. If something only makes 2% of the runtime, doesn't matter how fast you make it, you're saving yourself basically nothing. Focus on those big top consumers in your runtime. Some final resources if you want to read up more about these. So the logging framework, Tim Hall's always useful articles on how to use SQL Trace, 146 Trace, and so on, and the docs on the hierarchical profiler. So that's all. I'll leave that slide up for a little bit in case you want to capture it or anything. Any last questions or comments before we wrap up? Thank you all for joining me. I hope you enjoyed this. More importantly, I hope you learned something. Hope to see you again next time, and stay safe and stay healthy.